All right, so this is the idea of the central limit theorem, the concept here. Let's say we have a population of 200 people. And that population, the average, the mean of that population for some statistic is mu. The standard deviation is sigma. So this is the mean and this is the standard deviation. Now, let's say from these 200 people, we get 10 random samples of everybody in here. So I first pick 20 people from here, randomly pick 20 people, calculate the average of those 20, that's X bar 1. So now I'm down to 180 people, because 20 of them are in this first sample. I randomly pick 20 more people from the 180 that are left. That's sample 2, and I calculate the average of sample 2. Now there's 160 people. I randomly pick 20, and so on and so forth. And by the time I'm done, the last 20 people left will be, and then I take the average, that'll be the average of the 10th sample. So I've got 10 samples, 20 people in each of these samples gives me a total of 200 people. Now think about it. The average of each of these, because there's 20 people in each of these samples, the average is going to be pretty close to the average of all of the people, right? Because these are samples. So each of these are going to be pretty close to the average of the entire population. So what happens is when I graph the distribution of these averages, that's this red graph, that distribution is going to get squeezed down, and its standard deviation is going to be a lot smaller because it's not as spread out. It makes sense because each of these have a sample of 20 people, and each of these averages is going to get closer to that. So that's the basic idea of the central limit theorem. And the standard deviation of this red graph, again, is the standard deviation of the entire population divided by the square root of n. N in this example is 20 because each of these samples, the size is 20. So in this example, n would be the 20, and the denominator would be the square root of 20.